Welcome to today's class. Today we are going to learn about a topic. The topic is known as ARP. ARP stands for Address Resolution Protocol. ARP stands for Address Resolution Protocol. Okay, so why do we need an address resolution protocol? There are two types of addresses that we mainly use for network communication. One is the hardware address and one is known as the logical address. IP addresses are known as the logical address and MAC addresses are known as the hardware address. MAC address of a device, it is made. Okay, it is given to the particular device when the device is actually made. IP address, so whenever we are getting connected to one particular network, we'll be getting the IP address. Okay, so if you see here, you can see IP configuration of this particular PC that I'm talking to, and there is something that is known as the physical address also. Okay, the physical address is also here. Go to fast Ethernet 0/0, you will get 00602F485B49. This is the physical address of this particular device. Whenever a PC wants to communicate to another PC on the same LAN, it won't be using the IP address, 32-bit IP address. Instead of this 32-bit IP address, the PC will be using this 42-bit MAC address for communication purposes. The PC will be using the 48-bit MAC address for communication purposes. There are two types of addresses. One is IP address and one is MAC address. MAC addresses are the hardware address and IP addresses are known as the logical addresses. Okay, so MAC address of a system is given to the system when the system is actually made. So it won't change. IP address can change. So when an Ethernet frame is receiving to switch, first it will check what is the MAC address of that particular PC. What is the MAC address of that particular PC? So address resolution provides a mapping between two different forms of addresses, a 32-bit IP address and the 48-bit MAC address details. It is mentioned in RFC 826. It is mentioned in RFC 826. So if you want to learn more about R, you can refer RFC 826. RFC means request for comments, where like the entire protocol of ARP is actually mentioned. Okay. Now, this is one single LAN. This is one single LAN. This is one single LAN. So imagine that PC1 wants to communicate something to PC7. PC1 wants to communicate something to PC7. Right now, we just learned that if we wanted to communicate over the same LAN, we want the MAC address details of PC7. By default, this PC1 doesn't know the MAC address details of PC7. By default, the PC7 doesn't know the MAC address details of PC7, that is 192.168.10.6 MAC address details. So what this PC will do is that this PC will create a packet. That packet is known as R packet. This PC will create a packet that is known as R packet. Okay. I'll show you the step-by-step process. I'll use a command. The command is known as ping. Ping is a command that we use to check the connectivity between two different devices. Ping 192.168.10.6 is the IP address of that particular PC. Before I click enter, I'm putting on simulation mode. If anybody is using packet tracer, they can also use simulation mode. So you can see what are the steps that is going to happen, the step-by-step process. Okay, so ping use a protocol. That protocol is known as ICMP. ICMP means Internet Control Message Protocol. It is used to check the connectivity between different devices. Also, it does error reporting because IP by default, it's not a reliable protocol. IP by default, it's not a reliable protocol. Okay, so in ICMP, whenever we were sending an ICMP packet from source to destination, that is from 10.1 to 10.6, we will be requiring the MAC address details. So in the ICMP field, in ICMP packet, there is a field which we should mention the MAC address details. So first PC, whenever the PC is not having the MAC address details of 10.6, the PC will create R packet. PC will create an R packet and it will open this R packet. Okay, this R packet is a address resolution protocol which will map the IP address to the MAC address. So PC is creating a request. Okay, this is PC1's MAC address 00E0B084A052. This is PC1's MAC address, and we don't know the destination. This is a source MAC address. This is the destination MAC address. Destination, we don't know whose 10.6 MAC address. So we'll do a broadcast to the entire network asking for who is 10.6. So the source IP address is the PC1 itself, 192.168.10.1, and destination IP is 192.168.10.6. Clear? Now, since we don't know the destination device, we create an R packet. This R packet will be getting broadcasted to switch. Switch will broadcast that message to all the devices except the one it received. Switch will send this message to all the devices except the one it received. Okay, finally, 10.6 understood this IP address. Okay, I am 10.6. I am 192.168.10.6. All other PCs, this 10.2, 10.3, 10.4, 10.5, 10.7, 10.8, they rejected the packet just because they are not the IP address which ARP was looking for. Now, we'll go to PC7. We'll open PC7. Now, when the R packet is received by PC7, immediately PC7 has a table. That table is known as R table. Okay, it's a table which it will store the MAC address details. It will store the MAC address details of the particular IP address. So whenever PC7 received the packet, PC7 immediately learned PC1's MAC address details. If you see here, guys, you can see the request was coming from 192.168.10.1, and the physical address of 10.1 is 00E0B084A052. This is a dynamic entry. We learn this address dynamically once we receive this particular frame on us. And before we receive this particular frame, it was a broadcast message. Here, if you see this FFFF.FFFF.FFFF, it's a broadcast message because we didn't knew the MAC address of 10.6. Finally, when 10.6 is responding back, okay, it is not a broadcast, it is a unicast message. 000BBE3E9484 A4. This is the MAC address of 10.6. And this is the MAC address of 10.1. And the source IP, who is sending this ARP reply? 10.6. And to which PC we are sending the ARP reply? 10.1. Okay. Finally, the ARP reply is going to switch, and switch is sending that back to 10.1. Guys, remember, this is a unicast message. ARP request was a broadcast message, and ARP reply is a unicast message. Immediately when 10.1, okay, immediately when this message is received in 10.1, 10.1 also immediately update its MAC table information. Immediately 10.1 also updated the MAC address details. And now the ICMP packet which was on hold. Guys, imagine this. You are sending a package. Okay, you are sending a package to your friend in Delhi. Okay, so you went to some courier service place where you wrap the entire packet and you write the sender's address and the receiver's address. But you typed his mobile number, his name, full name, his house name, everything you mentioned. But you forgot to mention about his house number. Okay, so the particular person, once he is reaching in Delhi, so he won't be knowing the house number. So what he will do? He will drop the delivery and he will call the particular person. Either he will call on your phone or either he will call on that particular friend's phone number and ask for the house number. Once he receives the house details, again he will reattempt the delivery again. Same like here, the ICMP packet, like whenever we wanted to communicate to the end device, we will be needing the MAC address details. We'll be needing the MAC address details. When we don't have the MAC address details, we use a protocol. That protocol is known as ARP. ARP stands for Address Resolution Protocol. Address Resolution Protocol provides a mapping between two different forms of addresses, a 32-bit IP address and a 48-bit MAC address. Okay. Again, now if you go here, we send 4 packets, we receive 4 packets, 0% of data is lost. Okay. So there is something that I want to show you. Now I'm pinging the same device again. I'm going to simulation before pressing enter. Now I press enter. Now, if you see, an ICMP packet is created. Okay. Like we learned, we need the MAC address details. But if you see here, the ICMP packet is traveling right now directly. You know why? I'll show you. Right now, if you see, all the ICMP packets are traveling directly. Coming back to PC1, no R packet was gone. No R packet was gone. See, we sent 4 packets, and how many packets we receive? 4 packets. Is there any loss? There is no loss. So how does this happen? Is because there is something that is known as R cache. Okay. R-A is the command to check your R table entry. So whenever we communicated between 10.6, the first time when we get the R reply back, we immediately updated that IP MAC address details of that particular IP address into our R table. Okay. We updated this R information inside our R table whenever we received it. If you go to PC7 and check also, you will get it. R-A. You can see the details of 10.1 and the MAC address of 10.1. Okay. Now you see, I'll show one more time. I'm pinging the same PC. 10.6 I'm pinging. No R packet is getting created because why? Because we have the R table information and we can delete this entry also. Okay. If you type R-D, you will delete the ARP entries. Now you type ARP-A for entries. No ARP entries are there. Come to PC6, ARP-D, ARP-A, no ARP entries are there. Now if you ping, again ARP packets will get created. Now if you ping, again 10.6, I'm coming to simulation so that you can see what are the processes that is happening. 10.6, ICMP packet created, ARP packet created because in PC's ARP table, there was no ARP information, guys. And we are sending it to Switch. Switch is broadcasting this message, except the legit PC. All PCs are dropping the packet. The legit PC is sending back this response back. And finally, the message is going back to this message is going back to PC1. Right now, PC1 updated PC1's R table entry, ICMP packet, which was on hold. Right now, we are sending this ICMP packet directly to Switch. Finally, the data is also reaching directly to Switch. Okay, this is one type of ARP. These are the details that are present in an ARP header. Hardware type, what type of hardware we are using, the protocol type, then the hardware length address. If we are using like 8.2 MAC address, like the volume will be 8. The protocol type, we have to mention operation, what is the operation that we are performing, whether it's an ARP request or it's an ARP reply. Then we have to mention the sender's hardware address, the PC who is generating this ARP request, we have to mention that. Then the IP address of the PC who is sending this particular ARP request. Then we have to mention the destination's hardware address and the destination IP address. Destination hardware address and the destination IP address. In the next session, we are going to learn about it. The topic is known as proxy. So see you guys there.